What's up, guys? My name is Adam. I am a scientist and a teacher, and I love science. I have my whole entire life. And what I want to share with you today is a little bit about flames and fire. You know, when we look at a flame, we see something that's reddish, maybe. We sense that it's a little bit hot. And we get this idea that, you know, we shouldn't touch it because the heat doesn't work well with us. This is obvious. But there's a lot more to a flame, right? And there's a lot of chemistry and a lot of physics involved there, which is really interesting, okay? So when we think about a flame, one of the most important things is that we need a fuel source. And you know this. If you have a car, right, and your car runs out of gasoline, well, that gasoline is providing a fuel source for a spark, for a flame in your engine, right? Without a fuel source, fire cannot sustain itself. But how can you describe that and how can you show it? That's why we have this experiment here. So, as the camera comes in, I'm going to elaborate on a little experimental setup, right? I'm doing this now with adult supervision. You guys could do this at home as well, all right? So now, before we start, I'm going to just explain to you what we have in front of us. So I'll turn on my light, okay? Now, let's look a little bit closer at what I've got here. This is a regular candle, circular, right? Nothing new here. You guys have seen this before. It's made out of wax, right? And there's a little wick, and that wick is made out of a material which is coated in a sort of fragrance or an alcohol, and that alcohol provides kind of initial startup. And the wax is also important because it helps maintain the flame. That's then in this little simple thing, this little silver. On the outside, I've put some duct tape, right? These are two pieces of duct tape put side by side, overlapping like that, and I've put the candle directly in the center. The other thing that I have are two glass jars of different sizes, okay? For our first experiment, I'm going to show you what happens when I place this glass jar on top of an open flame. I want you to think for 2 seconds before I do this about your own hypothesis. What do you think is going to happen, right? It's important in science that you always come to the table with your own idea about how you think something is going to move forward. And so just for 2 seconds, think about that. Okay, done. Now, hopefully what I wanted you to think about, or what I wanted you to think about, is that this bottle has a certain fixed amount of space inside of it, right? If you filled it with water and you poured that water into a separate cup, you would have a fixed amount of water. If you did it again and you poured it out, you'd always get the exact same amount of water from this one jar because it's glass and it has a finite volume, a fixed volume, in other words. So, when I put it down on top of the candle, I'm creating a vacuum seal. And what that's going to do is prevent any oxygen from entering into the bottom of the cup. Now, I haven't told you my hypothesis yet. Let's just do the experiment and see what happens. So I light my candle first. It begins burning at this particular color. Okay? This is a reddish color, and it's not very hot. It's not a very hot flame. Certainly you don't want to touch it, right? But a blue flame or a white flame would be a little bit more robust, a little bit warmer. So we see it's burning quite nicely. If we left for 45 minutes, it would probably look exactly the same, right? Given that it had enough fuel source. Now I do my first experiment. I place the bottle on top of my flame. I've now created a vacuum, a seal. No oxygen can enter into the bottle, and what happened? My flame went out. That might have been your hypothesis. If it was, good job. If not, let's talk about that. As I said, there's a certain fixed volume inside this bottle. That also means that there's a certain amount of oxygen which can be held in this bottle. And once I created the seal with this duct tape, that oxygen began to get consumed by the flame itself. Okay. That is the first basic principle. A flame consumes oxygen in the air around it. Now, let's talk about this a little bit more. What I'll do next is I'll bring out a computer. on this computer, I have a stopwatch set up at stopwatch.com. For legal reasons, I had to say that. Now, what I'm going to do is light my flame, and then as soon as I place this glass jar down, I'll press start, okay? What we're going to do is count how long it takes for this flame to run out, okay? So, let's begin. Again, I start by lighting my candle, okay? We see the flame just as we did before. Now what I'll do is I'll get my bottle in position, and just before I place it down, I will activate my countdown timer. I put this here so that you guys could see it as well. All right, at home or in your classrooms, I want you to try and determine exactly at what time the flame dies out. Okay, are you ready? 1, 2, 3, go. And there. Okay, what do we have? That worked out pretty nicely. 10 seconds, 10.717 seconds. So it's kind of close to 11 seconds in total, right? Let's make a note of that. I want you to write that down on paper. Okay? We've got 10.7 seconds total. In order to verify our results from the first trial, I'm going to do it one more time. What I'm doing now is moving the jar around, right? By moving it around like this, I'm getting out any of the gas which was produced from this flame and hopefully refilling it with some oxygen, okay? If I went back and did it immediately, maybe it would have a less time because it couldn't totally refill. So, again, I get my finger right on the start button. 3, 2, 1, go. Flame is going well. Flame is going well. Keeping an eye on it. And close. Done. I have now 10.890. I'm going to write that down. 10.890 seconds. Okay? Keeping track of all this on my chart. Okay? I'll do one more trial because in science, 3 trials are usually good. Kind of allows you to take an average at the end. So for the third trial, I relight. Candle still has more than enough wax, so we're not worried about that. I've shaken my cup a bit so that we can get refreshed oxygen, and my clock is set back to 0. Here we go. 3, 2, 1, go. Flame's doing well at first. Its fuel source is readily available. Begins dwindling, and it's out. 9.13 seconds for trial 3. So with those 3 trials now I can calculate an average. Right? I did this on the side, and you can do it at home, but essentially by adding up these 3 numbers and dividing by 3, I can find the average time that it took for the flame to be extinguished. In this case, the average was 10.21 seconds. And I'll box that just to keep it in mind. Okay? Very good. Now, remember, I initially showed you 2 jars. Alright? I had a small jar, which we've been doing an experiment with. I also had this larger jar. Okay? Now, given what I've been saying, I want you to hypothesize as to what you think the difference will be in this larger jar and this smaller jar. Okay? I'll give you a second to think about that while I make a new note on my graph paper here for the big jar. We're going to do essentially the exact same thing. We'll have different trials, and with each of those trials, we'll take a time measurement. So I open this up again, clear, bring it over to start. Now, I'm going to move this out of the way for now. Okay? We've got our finger on the start button, shaking my container a little bit, even though it shouldn't really matter because this one we've never done the experiment with yet. So, I relight. We've got our flame. You see, it's doing quite well. Doing very well. Now, as I bring it down, I'll start the timer. 3, 2, 1, go. So we form the seal. Flame's doing all right. It's doing not that bad, actually. But, of course, there's a fixed amount of oxygen in there. As the oxygen runs out, the flame gets smaller until it's all gone. Boom. And that's when it stops. What we see now is that we have 18.8 seconds. And I'll write that down on my graph paper. 18.80 seconds. I want to make sure that that timing is accurate, though. And I'll do it one more time. Shake the container, refresh the gas. I light, I reset my timer, go back to the start button, shake it out, Ready. 3, 2, 1, go. You guys know what happens here. You've seen it before. But just in the interest of science, we want to be absolutely certain that it's going to take just about 18 seconds each time. And the flame is out. We're at 17.16 seconds for our second trial run. Trial 2 is 17.16 seconds. Lift it up. Shake it out. Shake it out. Okay. This is the last try. Start it. Turn it towards you guys. Make sure everyone can see this. Clear. Go back to the start button. Now, 3, 2, 1, go. And does alright for a bit longer this time. We watch it and there. 16.966. Trial 3. 16.96. Now, I'm also going to do an average here. So, I found my averages, right? What I found is that my second jar, the bigger one, after 3 trials, has an average time of 17.64 seconds. And again, what that means is that it takes an average of 17.64 seconds until all of the oxygen in this glass is consumed and the flame goes out. If you remember, we also did the experiment with the smaller one. For that one, we found an average time of 10.21 seconds. So, what's the difference here? What we're essentially seeing is that bottles of 2 different sizes have 2 different volumes. In other words, each of these can hold a different amount of gas. And the gas that we're interested in now is oxygen. For the larger bottle, the larger container, more oxygen gas means more fuel for our fire, which means longer time until it gets extinguished. On the other hand, the smaller bottle has a smaller volume and therefore can hold a smaller amount of gas, and in this case, oxygen. When we put it down on the flame, there's less oxygen available for our fire, and so less time goes by until the fire goes out and there's no more gas left. What we're talking about here is called oxidation. It's the process of consuming oxygen, in this case, right, and producing a flame. In this particular flame, there is we give off heat. Okay? Science is excellent, and when you see something as simple as a flame next time, I want you to think that there might be a different scientific explanation underlying it, something that you can investigate, something that you can experiment with even in the confines of your own home. All right? The scientific world is really quite fascinating, and small experiments like this can sometimes lead to great insights. Thank you very much. My name's Adam. Take care.